Hello everyone. Today I am going to make an audio recording for visually impaired student of textbook of organic chemistry by A.Singh and R.Singh. And topic is aryl diazonium salt. This class of compounds is recognized by the presence of the functional group N triple bond N diazonium ion directly bonded to an aryl group. The aryl diazonium ion Ar N triple bond N form salt with anions, that is chlorine, bromine, NO2, HSO4, BF4, etc. These salts are known as aryl diazonium salt. Nomenclature. Diazonium salts are named by appending diazoniums to the name of the parent aromatic compounds followed by the name of the anion. Hence, the diazonium salt derived from arenes are assigned name as arene diazonium salt. For example, benzene diazonium chloride, benzene cupid N2 positive plus Cl negative. Structure. The electronic structure of diazonium salt is written as. Therefore, the diazonium cation is resonance stabilized, the positive charge being distributed over the to an atom. The stability of aryl diazonium salts related to alkyl diazonium salt Rn2 positive X negative is also because of resonance involving the benzene ring. Hence, the CN bond acquires partial double bond character and is stronger than CN bond in alkyl diazonium salt. The aliphatic diazonium salt are unstable because R group is incapable of participating in resonance. In alkaline solution, the diazonium ion undergoes a structure change producing diazohydroxide and the following equilibria exist. Ar single bond N positive, triple bond and 1 lone pair is diazonium ion, 2 OH negative ion and Ar N single N lone pair to double bond N lone pair OH diazohydroxide, and it at equilibrium exists Ar N triple bond double bond N single bond O diazotate ion. In acid solution pH 5 to 7, the formation of diazonium ion is favored, while in strongly alkaline solution, the diazohydroxide that is obtained gives anti and sin diazotate ions. Anti-diazotate ion and syn diazotate ion. Preparation. Aryl diazonium salt are achieved by the addition of an aromatic primary amine with HNO2 at about 0 to 5 degrees Celsius. The nitrous acid is achieved in situ by taking sodium nitrite and mineral acids HCl or H2SO4 in the reaction mixture. Aromatic primary amine plus HNO2 plus HCl give rise to 0 to 5 degrees Celsius to convert ArN to positive Cl negative plus 2H2O. Aryl diazonium chloride. The method of converting an amine to the diazonium salt is termed as diazotization. The procedure of diazotization may be shown by taking example of the preparation of benzene diazonium chloride from aniline. Preparation of benzene diazonium chloride. It may be obtained by the addition of concentrated solution of 1 mole of sodium nitrite dissolved in 3 moles of hydrochloric acid at 0 to 5 degrees Celsius. C6H5NH2 plus NaNO2 plus HCl at 0 to 5 degrees Celsius gives benzene diazonium chloride, that is 6,6H5N2 positive Cl negative plus NaCl plus 2H2O. Reaction in which N2 positive X negative is replaced. First, reduction to arenes, replacement of N2X by H. A diazonium salt is reduced by hypophosphorus acid to produce the respective arenes. C6H5N2 positive Cl negative plus H3PO2 plus H2O give rise to C6H6 plus N2 plus H3PO3 plus HCl. This reaction permits the use of NH2 group to direct the orientation of an aromatic electrophilic substitution reaction followed by its removal, deaminations. Second is synthesis of aryl chlorides, aryl bromides, aryl nitriles, replacement of single bond N2X by chlorine bromine CN. When a cold diazonium salt solution is treated with cuprous chloride, cuprous bromide or cuprous cyanide, the product is aryl chloride. aryl bromide, or aryl nitrile. This reaction are called Sandmeyer reaction. Benzene diazonium chloride plus CuCl give rise to chlorobenzene plus N2 gas involved. Benzene diazonium chloride plus CuBr give rise to bromobenzene plus N2 gas involved. Third is N2 positive plus Cl negative is benzene diazonium chloride plus CuCN give rise to at heat benzene nitrile plus N2 gas involved. Mechanism. Free radical mechanism is involved. Cuprous halide cyanides act as catalyst. It gives the electron for the formation of phenyl free radical. Benzene to N2 positive plus Cu positive. First step is benzene plus N2 plus Cu2 positive. Second is benzene plus Cl negative. Second step to benzene chloride plus electron involved. Cu2 positive plus electron is third step to give Cu positive. The aryl nitriles prepared by Sandmeyer reaction can of course be hydrolyzed to carboxylic acid. This provides a useful technique of introducing COOH group in the benzene ring where other techniques are not applicable. O-nitroaniline give rise to HCl at presence of HCl and NaNO2 at room temperature give rise to NO2, N2 positive plus Cl negative. Then CuCN used Cn attached to the benzene ring, then NO2 at para position. Cn are attached to the para ortho position, then S2 involved to give rise orthonitrobenzoic acid. The reduction of nitriles with sodium ethanol or LiAlH4 produce the corresponding amine. Benzonitrile plus 4H at the presence of LiAlH4 to give C6H5CS2NS2 benzyl amine. The application of copper powder in place of cuprous salt is common, and then the reaction are called Gattermann reaction. Here N2 positive Cl negative at the presence of Cu HCl give rise to ArCl plus N2 gas involved. Second is Ar N2 positive Cl negative at the presence of Cu HBr to give ArBr plus N2 gas evolved. Third is Ar N2 positive Cl negative at the presence of Cu KCN give rise to ArCN plus N2 gas evolved plus KCl. Third is synthesis of phenol, replacement of N2X by OH. Aqueous solution of the diazonium salt is acidified and strongly heated to form phenol. C6H5N2 positive Cl negative plus HOH at the presence of H2SO4 and heat to give rise C6H5OH plus N2 gas evolved plus HCl. This is a useful reaction for preparing substituted phenol not achieved by electrophilic aromatic substitution of phenol. M-nitroaniline at the presence of H2SO4 and NaNO2 at 5 degrees Celsius to give rise benzene S2N2 positive HSO4 negative and meta positions to NO2 group presents, then again in the presence of H2O at 160 degrees Celsius to convert meta-nitrophenol. Fourth is synthesis of thiophenols, replacement of N2X by SH. Reaction of diazonium salt with potassium hydrosulfide produces thiophenols. C6H5N2 positive Cl negative plus KSH give rise to thiophenols plus N2 gas evolved plus KCl. Fifth is synthesis of aryl fluorides, replacement of N2X by fluorine. The diazonium salt is treated with fluoroboric acid when diazonium fluoroborate C6H5N2 positive BF4 negative precipitate. This is isolated, dried and heated to give aryl fluorides. This method of preparing fluorobenzene is called Skiman reaction. C6H5N2 positive Cl negative plus HbF4 give rise to C6H5N2 positive BF4 negative plus HX. C6H5N2 positive BF4 at the temperature 100 degrees Celsius to give fluorobenzene plus ento gas evolved plus BF3. 6 is synthesis of aryl iodides, replacement of by iodine. When aqueous solution of a diazonium salt is heated with excess of potassium iodide, aryl iodide is achieved. C6H5N2 positive Cl negative plus Ki at heat to give iodobenzene plus KCl. Seventh is synthesis of nitro compounds, replacement of N2X by NO2. When diazonium fluoroborates are heated with aqueous sodium nitrite, the product is a nitro compound. C6H5N2 positive Cl negative at the presence of HbF4 to give C6H5N2 positive BF4 negative, again at the presence of aqueous NaNO2 at copper presence and the heat to give nitrobenzene plus N2 gas evolved plus NaBF3. This method is adopted for preparing nitro compounds which are difficult to prepare otherwise. Metanitroaniline at the presence of first is NaNA2 oblique HCl, second is HbF6 to give at benzene ring to N2 positive, BF4 negative at para position NO2 group present, then again aqueous NaNO2 Cu oblique heat, then give para dinitrobenzene. Eighth is reduction to aryl hydrazenes. When reduced with sodium bisulfite or stannous chloride, aryl diazonium salt produce aryl hydrazenes. C6H5 N2 positive Cl negative plus 4H at the presence of NaHSO3 to give phenylhydrazine C6H5NHNS2. Phenylhydrazine is utilized as a reagent in the identification of carbonyl compounds and sugar. Ninth is synthesis of biaryls, replacement of N2X by aryl. The diazonium salt solution is made basic and treated with liquid benzene to form a unsymmetrical biaryl. At 3C at benzene and N2 positive Cl negative presence, then at the presence of benzene NaOH at the 5 degrees Celsius to give 4-methyl biphenyl plus N2 gas evolved and plus NaCl. The coupling of aromatic rings as above is called Gomberg reaction. Reaction in which N atoms are retained. 10th is diazocoupling reaction. Diazonium salts easily react with phenols and dialkyl anilines to form highly colored derivative called azo compounds. Ar single bond N, double bond N, single bond Ar. For example, C6H5 N2 positive Cl negative plus phenol at this light alkaline to give C6H5 N double bond N at benzene ring OH plus HCl. It means para-hydroxyazobenzene orange solid. And second is the 6H5N2 positive plus N dimethyl at the slightly acidic medium to give C6H5 and double bond N benzene ring to convert NCS3CH3 plus HCl is yellow solid. Such reaction in which the diazonium ion is joined or coupled to the ring of a phenol or an aromatic amines are called diazo-coupling reaction. While the coupling with phenols is carried in slight alkaline solution, the coupling with aromatic amines is carried in slightly acidic solution. Mechanism: diazo-coupling reaction takes place by typical electrophilic aromatic substitution mechanism. The benzene diazonium ion act as an electrophile and attack the para positions of phenols and aromatic amines. Recall that phenols and aromatic amines are activating compound. The OH and NH2 group increase the electrodensity of the ring at the ortho and para positions. As we can see that these mechanisms, benzene diazonium chlorides act as electrophile and it attacks the para position of phenol, and phenols and aromatic amine are activated compounds and the OH and NH2 group increase the electrodensity of the rings, and second step H positive is the removal then to give product para hydroxyazobenzene. Diazocoupling reaction with phenol and aromatic amines produce a large number of dye, the azo dyes. Second is reaction with amine. Diazonium salt react with primary and secondary amines in mildly alkaline solution to form diazoaminobenzenes. Here the coupling takes place at the N atom of the amine and not at the ring. However, the diazoaminobenzene on heating in acidic medium rearranges to give the C-azo compound. C6H5N2 goes to Cl plus aniline NS2 at C6H5 at the presence of CH3COONA to give diazoaminobenzene. Second is C6H5 and double bond N NH at benzene ring at the presence of H positive oblique heat and rearranges to give para-aminoazobenzene color compounds. Thank you.